Let's now look at some exam questions regarding random variables. The first one is this one. It is a paper 6 from June 2007. And the question is this. A vegetable basket contains 12 peppers, of which 3 are red, 4 are green, and 5 are yellow. 3 peppers are taken at random and without replacement from the basket. Find the probability that the 3 peppers are all different colors. That's the first question, and that's what we are going to focus on to begin with, and then I'll go back here to get the other 2 questions. All right, so you have 3 events. Each one of these corresponds on someone taking a pepper out of a basket that contains 12 peppers. So the best way for you to deal with this is to build a probability tree, okay? Up until 3 events, you can do it. It's not going to be the simpler probability tree, as you can see over here, but you can do it, all right? There is a way for you to solve these questions without the use of the probability tree, but I want you to get a visual representation of what's going on first, and then I'll go to the more analytical method. All right, so once the first pepper is taken, this corresponds to this event over here. It can be red, green, or yellow, and you have the corresponding probabilities here. It is obviously without replacement, so the number in the denominator goes down, and the numerator will correspond. It will go down only if it is the right pepper being taken out. So in this case, as you can see, the number of red peppers decreased because this one was already taken over here, so you only have 2 left, but the number of green and yellow remain the same, and so forth. Same thing goes for the third event, all right? So the probability tree is done over here, and then you could use it to calculate what was being asked, which was the probability that all peppers have different colors. If they have different colors, these are the possible combinations: red, green, yellow, red, yellow, green, green, red, yellow, green, yellow, red, yellow, red, green, and yellow, green, red. You just follow the path for each one of these, multiplying the corresponding probabilities, add everything together, and you will have this value. You will notice that for each one of these, the corresponding probability will always be 1 over 22, all right? What is the other method that did not involve you building the probability tree? Well, you know that you need to take 1 red pepper out of 3, 1 green pepper out of 4, and 1 yellow pepper out of 5. And how many different peppers did you have once you would take all of these 3? Basically, you would take 3 peppers out of 12. And the order doesn't matter. All it matters is that they all have different colors. Okay, so as you already learned, this would correspond to 1 red out of 3. That's combinations 3, 1. 1 green out of 4, that's combinations 4, 1, and 1 yellow out of 5, that's combinations 5, 1. Out of what? Out of combinations 12, 3. Okay, so just plug this in a calculator. This would be a much simpler method, and you would have the same result as over here. Okay, just for you to understand what this means, the visual representation of this much quicker method is over here on this tree. But if you would do just this, that will be fine. Okay, I want to make this very clear. Then the probability that you have exactly 2 green peppers. Again, using the tree, these are the possible outcomes. So red, green, 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 red, green, 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 and now no green, green, yellow, green, and yellow, green, green. All right? Let me just check here one thing. Okay, so the corresponding probabilities are over here. I multiply for each one of these, all of them all together, then add the bunch, and here you have the overall probability. But again, we can use this method. So what do we want? We want 2 green out of 4, which leaves 1 that is not green out of 8. Out of how many possibilities? The same as before. You take 3 peppers out of 12. Okay? So just plug this in a calculator and you have exactly the same result. All right? Then question 3 said, let me just take this out of here. The number of green peppers taken is denoted by the discrete random variable x. Draw up a probability distribution table for x. Now, x is the number of green peppers out of 3. So what options do you have? You have the option in which x is 0, so you have no green peppers. You have 1 green pepper, 2 green peppers, or 3 green peppers. Now that we know this formula, we are just going to adapt it. If you have no green peppers, so that's 0 out of 4, which means that you have 3 out of 8 that are not green. Over, the denominator is always the same, 3 peppers out of 12. Okay, so here you have the probability when r is 0. When r is 1 means you only have 1 green pepper, so 1 out of 4 times 3 out of, this is not supposed to be 3, this is supposed to be 2. I wrote 3, but you have 2. Okay, 2 out of 8, again divided by 3 green peppers, 3 peppers out of 12, regardless of the color, and this is the result. The probability that x equals 2, we just got it before, that's 12 over 55. And the probability that x equals 3, that's 3 green peppers out of 4, no pepper of any other color out of 8, and 3 peppers out of 12. Plug everything in the calculator, and this is what you get. Now the probability distribution is represented in this table. Okay, are from 0 to 3, and here the corresponding probabilities that we just got. And that will be it. Okay. The other 2 exam questions are much simpler, particularly the last one, but even this one. This is from paper from 2010, paper 61, and it's the first question. The probability distribution of the discrete random variable x is shown in a table below. Given that the expectation is 0.75, find the values of a and b. A and b are over here. Okay, so I reproduce the table here again. What is the expectation? The expectation is the sum of the product of these two, right? So just go ahead and multiply this by this, plus this by times this, plus this times this, which is 0, plus this times that. And this has to be equal to 0.75. At the same time, the sum of all possible probabilities have to be equal to 1. So here you have 2 equations that will allow you to get the 2 unknowns, a and b. In this case, after simplification, I used what? I used elimination. I just eliminated b. I got a, and then using the value of a, just substituted on either one, and I'll get the value of b. So all of this, and you have 3 points. Next one, I think it's even simpler. It's a paper 6 from November 2007. It's question 2. The random variable x takes the values -2, 0, and 4 only. It is given that the probability that x equals -2 is 2p, that x equals 0 is p, and that x equals 4 is 3p. Then find p. Well, we basically already have done this on this question. This is the table, right? So you know that if you add all of this together, this has to be equal to 1. So p equals 1 over 6. Okay, we can now make an update of that. I didn't bother to do that. In order to get the expectation, that's the next question. It's just, again, the product of r by its probability. I'm just going to substitute here p by 1 over 6. So, for example, this is going to be 2 over 6, which is 1/3. I didn't even do that. I just put it there. Everything in a calculator, added everything together, and I got 4/3. And the variance is the sum of r squared times the corresponding probability, all of the options added together, minus the expectation square. So I just plug in the values. The expectation is over here. I square it, and here is the result. How many points for this? A total of, okay, 6 points. Basically 6 free points.